Okay, so I need to discuss some of the special cases involved in our section 6.4. This is the second part of that section. We did all the normal things. When we have a compound statement we involving an and, we expect to make our number line and for the shading to overlap in the middle between the two dots. And if it happens to be an or statement, we expect the number line to have the shading on the outside edges, kind of pointing away from each other. That's not always going to be the case, so I got 4 examples to run through here. I started solving on this problem number 1 here, and even set up a number line to get it. We subtract 1, and we're dealing with numbers greater than 2, and after we subtracted 5, numbers less than or equal to 0. How we would do these problems, typically, we would make a quick sketch of each individual piece above our number line and look for the overlap. Filled in circle pointing to the left here. Okay, I just drew my 2 pieces and they do not overlap, which is what we need to see with an and statement. So there are no numbers that satisfy both pieces, thus there's going to be no solution for us. You can either make the symbol as your answer for no solution, or actually write down the phrase no solution. Okay, for problem number 2, I went ahead and got a head start here. When you divide by the -1, notice how it switches the inequality sign around and you end up with a +4. Quick sketch of what these are going to look like. Open circle to the right of 4. It's going to be an open circle at 10 and going to the left. And with the or statement, we have, remember our job is to keep all shading anywhere there's a line whatsoever. So keeping everything, which is exactly everywhere on this number line, you go ahead and just shade the entire number line. Bold arrow on both sides. And with every single number making it true, that's what we've had on some equations in the past, and we said all real numbers. So you can write the phrase all real numbers, or of course make our symbol for it. Capital R with a double bar. I went ahead and set number lines up for problems 3 and 4. No solvings involved. X is by itself everywhere. So quick sketches and we can get to finalizing the number line. X is less than or equal to 2 is going to be a filled in dot pointing to the left. X is less than or equal to 6, also filled in dot pointing to the left. Because it is an and statement, you want to keep where the 2 individual arrows are overlapping each other. So you really want a filled in circle at 2, and just everything to the left of there is what you're going to want shaded. So X is less than 2 is really the only part you need written in your answer along with that picture of the number line. Problem 4, once again, doesn't work out quite how we expect the normal or statement to work. This was in our special cases. We're going to make a filled in dot pointing to the right, starting at -9. -5, filled in dot, pointing to the right as well. And with an or statement, we're supposed to keep everything we see, if there's any line whatsoever. So, starting with the furthest point left, that there's a single line, and we're in a shade. Everything to the right of that. With that being the case, the x is greater than or equal to -9 is the entire answer. We don't need the second half of that statement at all. It doesn't really affect our number line or our answer. Problems 5 and 6 will be the last 2 problems of this screencast. Different set of directions here. Write a compound inequality to describe each graph. When you're doing that, my suggestion is decide whether it's an and statement or an or statement before you even think about any of the numbers. Remember, and statements what we expect to have the shading in the middle. So problem number 5 is an and. Okay, the second thing I suggest is decide the 2 numbers that are at the endpoints. This is a 2 and 6 that we're dealing with. I'm leaving myself a little room to fill in other information. what will the signs be based on is it a filled in circle or an open circle, and which side the shading is from it. So at the 2, you have a filled in circle shading to the right. That's going to be a greater than or equal to sign. At the 6, we have an open circle with shading to the left of it as a less than symbol. This happened at the 6, and then you just make up a letter to represent the numbers we're talking about. So this compound inequality, double check it, x is greater than or equal to 2, filled in, shading to the right, and x is less than 6, open circle, shading to the left. So the compound inequality with an and or an or in it is what we're looking for as an answer when the directions look like this. Problem number 6 I made up over here. The shading is on the outsides of the number line, pointing away from each other. That's what we think a typical or statement is going to look like. Not always, but typically. The two numbers we're dealing with are 0 and 4. This is an open circle with shading to the left. That's a less than sign. Closed circle shading to the right. Greater than or equal to. Compound inequality for that graph in number 6 is x is less than 0 or x is greater than or equal to 4.